All right, so section 6.6 is about solving equations with rational expressions. Remember, rational expressions can have variables in the numerator and denominator. All right, so on your study guide, I'm actually beginning on the next page with example 1. All right, we're going to do about 5 examples here to go through these. So this is really just solving for x. That's our goal here, is to solve for x. It's just now we have that variable in the denominator. So whenever you have a whole number, let's make it a fraction to begin with. Okay, maybe we need to do that depending on what the denominator is, we can see from there. But the very first thing we're going to do is find a least common denominator. And just to keep that separate, I'm just going to write down the LCD, and then we're just going to write it down so we know what it is. So if I look at this, I might want to put parentheses around it, your choice. I have an x minus 2 once, I have an x minus 2, and I have a 1. So we have an x minus 2, I already have it, and the 1's already there. So that's our least common denominator. Now what we want to do is we want to get this out of the denominator. So here's how we do that. We multiply every single numerator by the LCD. Okay? So to begin here, we're going to have an x, and we're going to multiply it times the LCD, and then leave our denominator there. Okay, so here we're going to multiply the numerator by the LCD. Numerator by the LCD. Now, do I really need to show that over 1? No, so really I didn't necessarily have to do that. So that's okay. You don't necessarily have to put that over 1 if you don't want to. Didn't really make a difference here for us. So that's fine. All right, now we're here. So now let's cancel anything common factors or anything that's common in each of our terms here. So here we can cancel an x minus 2 and an x minus 2. So what we're left with there is just an x. Right? So here equals x minus 2, x minus 2. We're left with a 2. Now here, we have to go ahead and distribute. We don't cancel anything out of the denominator because we didn't have anything. So just distribute. So 2 times x and 2 times a negative 2. Right. So now we're going to take this and we're just going to solve it for x. So let's simplify that. Let me just do an arrow there. Let's simplify this. So we have a 2x, and then 2 minus 4 is a negative 2. So let's get our x's on one side. It doesn't matter which side. So to keep it positive, and you don't have to do this, you could subtract 2x from both sides. That would be okay also. 2x minus 1x is 1x. We're trying to get 2 by itself, so let's add 2 to both sides. So x equals 2. Now, we didn't really talk about this so much on the last part, but we're going to talk about this with equations. We didn't talk about it when we just talked about expressions, but now that we have an equal sign in there and we're solving that, we want to be sure that our answer works. So think about this. If I were to substitute this back in, so really what should happen is I substitute it in for x here, substitute it in for x over here, and they should equal each other. But what happens when I put a 2 in right here? So when I check that denominator, and I'm just looking at the first part, so I would put a 2 in right here, and I would put a 2 in right here. And I'm just going to write it all out so you see what I'm talking about. Put a 2 in for x right here, plus 2. Don't have to put it over 1. So what happens here? That becomes 2 over 0. Well, what happens if this denominator is 0? So that becomes 0, this becomes 0. Well, 2 over 0, that's undefined. So that solution will not work. So this means it's undefined. Therefore, there is no solution. And you can do that, or you can do the empty set, whichever one you prefer. No solution. So that's why it's important when we're doing these equations that you do check that to be sure that, and what that is called is check the constraints. Well, if I put a 2 in there, that's going to give me something undefined, so that will not work. It has constraints in there, and x cannot be 2. So unfortunately, there's no solution on that. All right, let's look at example 2. So here we have Okay, so that's what we're going to start with. So the first thing we want to do is, before we can find the least common denominator, we have to factor these out if they factor. So let's begin with that. What do these have in common? Well, I can take an x out, and then I'd have an x, this divided by this divided by this would be 1. All right, this is a difference of squares. So that gives us an x plus 1 and an x minus 1. All right, now let's find the least common denominator. So let's look at our LCD here. We have an x. Okay, we have an x minus 1 here. And so we'll do an x minus 1. We have an x plus 1. And we have an x minus 1, which we've already written, so we don't write it twice. So now we're going to take each of these numerators and we're going to multiply it by the LCD. So here we're going to start with 2. We multiply times x minus 1, x plus 1 over our denominator equals, again, 2 times our LCD over our denominator. All right, so what we're going to do is cancel anything that we can cancel, so that'll help us simplify it down. So we can cancel the x minus 1s. Now these I can cancel, even though this is a 2x, it's 2 times x, right? And it doesn't have a addition or subtraction operation, so I can cancel these x's in that, when that happens like that. Okay, over here, let's see, we have an x plus 1 and an x minus 1 that cancel. So let's see what we are left with. Here we're left with a 2 times x plus 1. And then here we're left with a 2x. And that's it. So let's distribute the 2 through. Equals 2x. All right, so what happens here? You know, I'm looking at this and I'm looking at your example, and your example has a 1 here, because wouldn't this would be 0, right? Again, and it would be undefined. So I'm going to make a slight change. I'm sorry about this. I missed it on your study guide. Let's make this a 1. So the only thing that does is if this is a 1, then this, let's be sure, this is a 1 times this. So this is a 1. Sorry about that. I misread the guide. So then this is just going to be, on this side, just a 1x. Right? It's just this 1x, and I don't really have to show that 1. So we're just going to make it an x. All right, so we're going to bring that x down. That makes the problem a little bit better. Okay, all right, so let's, and I'm not going to redo this whole video just to show that. So, you know, it's a mistake. It's okay. We all make them. Not a big deal. All right, let's subtract x here. So 2x minus x is 1x. And we're solving for x, so let's subtract 2 from both sides. So x equals a -2. Now let's be sure if we were to put it back in here, that it would be okay and it checks out. So 2 over a -2 squared minus a -2. 1, -2 squared minus 1. All right, so -2 times -2 is a +4. So this would be 4 plus 2. So that would be 2 over 6 equals -2 times -2 is 4 minus 1. So 4 minus 1 would be 1/3. Well, 2/6, that reduces down to 1/3, right? So that would be 1/3 equals 1/3. So that checks out. So this would be our solution. All right, let's do another one. I'll try and copy it down right this time. How about that? All right, so let's take a look at this one. See, I need you guys here to say, hey, Ms. Stringer, you wrote that down wrong. All right, there we go. So here's our example 3. Let's find a LCD. First thing we have to do here is we have to, whoop, sorry about that. We got to factor this out. So we're going to factor this to an m plus 2 and an m minus 2. That's a difference of squares, perfect squares. All right, so let's see, what is our LCD? Well, we have an m plus 2 and we have an m minus 2. We have an m minus 2, which is already here, and an m plus 2, which is already here. So we don't write them down again. Okay, so there's our, all right, so let's now take our numerators times the LCD. So here we have a 2m times m plus 2m minus 2 over our denominator, okay, plus 1 times over our denominator equals 2 times our LCD, takes up some paper, over m plus 2. All right, so I just multiplied the numerator by the LCD. Now let's do our canceling. So just top and bottom individually for each term. So just looking at this term, m plus 2, m minus 2. So we're left with a 2m. Okay, here our m minus 2's cancel out. So plus 1 times m minus 2. And would you agree that I really don't have to show the 1 there? And I can put parentheses around this. Either way is fine. All right, equals, let's see what happens here. Cancel out our m plus 2's, and we're left with a 2 times m minus 2. All right, so here we have 2m plus 1m is 3m. Let's distribute 2m minus 4. Solve this for m. Okay, and let's get this variable by itself here. So m is equal to a negative 6. Now I can look up here and say, okay, I can put a negative 6 in there. It's not going to give me 0. It's not going to give me 0 here. Negative 6 here is going to give me 36 if I square it minus 4. So that's not going to give me 0 either. So I know that this is going to be the solution. Okay. So I just want to be sure that you recognize that. So if there is one that, you know, has a constraint and it doesn't work, you're going to need to tell me that. But I don't necessarily expect you to have to go back and show this work, as long as you can look back up and recognize that it would not be undefined, then I'm good with that. All right, so let's go on to, we have 2 more examples here. So here's number 4. All right, so here's the next one. So let's go ahead and factor this. Difference of squares, plus 1, minus 1. Okay, and then that's gone. All right, so let's find our LCD. So our LCD is, here we have an x minus 1. We have a 2, and I'm going to put the 2 in the front. I kind of like to have the 2 in the front. And then we also have an x plus 1. So we'll do an x plus 1. We already brought the x minus 1. We already have that showing. So, okay, so least common denominator. Now we're going to multiply that times all the numerators. So this is going to be 1. And I'm just showing that so you see what I'm doing, but it's 1 times 2, x minus 1, x plus 1. Plus again 1 times this denominator. Oops, I forgot to put the denominator. So this is over x minus 1. This is over 2. And then equals 2 times 2 times x minus 1 times x plus 1. So I'm just taking this times this. So I just wrote it out. And then x plus 1 and x minus 1. Okay. All right, so here we're going to cancel the x minus 1s. So we're left with, you know, really that's just 1 times 2, right? So not a big deal. So 2 times x plus 1 plus, actually the 2's cancel out here. So we're left with 1 times an x minus 1 and an x plus 1. So here the x minus 1's cancel and the x plus 1's cancel, and we're left with 2 times 2, which is 4. So we're going to have to do this multiplication, multiplying these binomials using either, you know, the distribution FOIL, again, the box method, whatever's easiest for you. So let's distribute the 2 through. So here we have 2x plus 2. Now here we have x squared plus 1x minus 1x minus 1. And let's just keep simplifying. So do you see this 1x minus 1x will cancel out? That becomes 0. So let's begin with our highest exponent. So we want to write that in descending order. So x squared. Here we have just a 2x because these canceled out. We have 2 minus 1, which is 1. All right, so in order to solve for x, we're going to have to factor that, but we've got to set everything equal to 0. We've got to set that equation equal to 0. So let's do that first. Okay, so we subtracted 4 from both sides. Now we can set it equal to 0. This should be a pretty nice factorable one. I'm going to go over here, save a little paper here. So let's factor this. So split the x's. What multiplies to equal negative 3? Can we get a positive 2? So we know factors of 3 are 1 and 3. We need a positive 2 when we add those together. And then if we multiply them together, we'll see that that becomes a negative 3. So let's set each of these equal to 0. So x equals a negative 3 and x equals 1. Now let's take a look at those. And let's look back up here just to be sure. Can I put a negative 3 in here? It's not going to be 0. Negative 3, that's going to be a negative 2. Negative 4, that's not going to be 0. Okay, what if I put a 1 in here? Well, if I take this 1 and I put it in here, that's going to be 0. Oops. If I put a 1 right in here, it's going to be 0. So this would be undefined. So this one we don't use. So this is the solution. Sometimes they will both work. Sometimes neither of them work. Sometimes one will work. That's why you have to be aware. But you can't just look at that and see if I put a 1 in here, it's not going to work. If I put a 1 in here, it's not going to work. So if any of them become 0, it's undefined. So that means that's not going to be a solution. All right. And again, I just had put the negative 3 in here. That gave us a number, negative 4. Negative 3 gave us negative 2. Negative 3 gave us a negative 4. So that wasn't going to be 0. So we just double check that as well. All right. Last problem. We're not going to do the solving for a specified variable. That's another thing that we're going to cut out right now. So don't worry about that part of your study guide. All right, last one here, k squared. All right. So the first thing before we can find the least common denominator, we have to factor these out. So let's factor here. Okay, multiplied to equals 3, can I get 4? So 3 and 1, need a positive 4, and then multiply back to 3. So we're good there. All right, these have greatest common factor, they have a 2 in common. So let's get that 2 out of there. 2k divided by 2, 2 divided by 2. Okay, what do these have in common? Well, those have a 4. So let's take a 4 out of there. So k, 12 divided by 4 is 3. So let's see what our LCD is. So our LCD is going to be, we have a k plus 3. We have a k plus 1. We have a 2, which I'm going to write in the front. We've already written the k plus 1. Oh, we have a 4. So what does that mean? We have a 2 and a 4. We take the smallest number they both go into. So instead of using a 2 in there, I'm going to use a 4. Okay, I couldn't use 2 because 4 doesn't go into 2. So take these two, find the smallest number they both go into. All right, and then right here, these two. All right, and then we have a k plus 3, which is already written. All right, so let's take our LCD times our numerators. So here we're going to have 1 times 4, so let's just put a 4. And we'll have a k plus 3, k plus 1 over our denominator. Okay, plus, here 1 again times that, so 4 times k plus 3 over the denominator equals 3 times 4, which is 12. All right, let's cancel. So we're going to cancel k plus 1 and k plus 3. So here we're just left with a 4. All right, so here we can cancel, 2 goes into here once and it goes into here twice. All right, so our 2 and 4. We'll cancel out the k plus 1s. So what we're left with is a 2 positive, right? So plus 2 times k plus 3. All right, so 4 goes into here once and into here 3 times. Can cancel the k plus 3s. So we're left with a 3 and a k plus 1. All right, so let's just solve that for k. So we're going to go ahead and distribute right here. So 2k plus 6, distribute 3k plus 3. Now let's combine any like terms we have. So we write our variable and then 4 plus 6. All right, and we want our variable to be positive, so I would suggest subtracting 2k from both sides. If I subtract 3k from both sides, that's okay. I'm just going to have a negative k, and I'm going to have to divide by -1 at the end. So either way is fine, but I usually take the larger one, trying to keep it positive. Okay, so 3 minus 2 is a positive 1k. So let's get k by itself, so we'll subtract 3. So k is equal to 7. Now let's double check our answers up here. So I can put a 7 in here and get a number 10, put a 7 in here, get 8, put a 7 in here, get 8, put a 7 in here and get 10. So none of that's going to be undefined. So this is a solution. All right, again, don't worry about solving for a specified variable. We're not going to worry about that right now. Just kind of concentrate on this 6.6. All right, have a good one, guys. See you later.